Okay, the last set of identities that we're going to get are the Pythagorean identities. Now, the Pythagorean identities are based on the idea of Pythagorean theorem. A squared plus b squared equals c squared. And remember, when we had a circle, any point on that circle, if we had a circle, any point on that circle, we could draw a reference triangle. And in that reference triangle, the value on that circle was xy, and that x squared plus y squared gave us the radius squared, right? So anytime we had a circle, here's the x value, here's the y value, and here's the r value. And x squared plus y squared equaled r squared. Well, when we are working with a unit circle, so let's go back to the idea that we are working with a unit circle. In that case, r is always equal to 1, right? And so x squared plus y squared is always equal to 1 when we're on the unit circle. Well, there's one more thing we have to remember. On a unit circle, what value was found in x? In x, we could find cosine of theta. Cosine of theta equals x. So cosine squared theta is the same thing as x squared. And in y, we could find sine of theta. So sine of theta squared is equal to y squared. That's just a replacement. If cosine of theta is x, then cosine squared of theta is x squared. If sine of theta is y, then sine squared theta is y squared. And this is an identity. It says that if I have cosine and sine, if I square them, I will get 1 every single time. Now, the really cool thing from that is we can create two others, which I'm going to leave for another video, but the other two Pythagorean identities are tangent squared theta plus 1 equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. Now, I'm going to show you those two in another video, how I found them. But for now, just know these are the Pythagorean identities. So what do we do with those? We have them. What do we do with them? Well, let's take a look at this problem where I'm going to give you the sine value. It's positive, and cosine is negative, which means that this is positive in quadrants 1 and 2. Cosine is negative in quadrants 2 and 3. And so I know that my triangle is going to be in quadrant 2. And I could use another method. I could use a lot of methods. I could use this is y over r and find my x value and then find all the other trig functions. But watch what else I could do. I could use cosine squared plus sine squared equals 1 and solve this problem. Now, you may not like this method and you don't have to use this method, but you do need to know that it works. So let's take cosine squared, which we don't know what that is, cosine squared theta, plus sine squared theta. Well, we know what sine theta is. Isn't sine theta 2/5? So I'm going to put 2/5 squared, because that's sine theta squared equals 1. That's cosine squared theta equals, plus 4/25 equals 1. We're going to subtract. Cosine squared theta equals 1 minus 4/25. And so cosine squared theta equals 21/25. Now, when I take the square root of both sides, which I'm allowed to do, I will get cosine of theta equals the square root of 21, because I don't know what that is, over 5, because the square root of 25 is 5. Now I've got sine and cosine. I've got my sine value, my cosine value, and I can go on from there to find tangent by putting sine over cosine, and I can find all of my reciprocal functions as well. I can find cotangent, secant, and cosecant. Now, I would like to show you this problem from a slightly different perspective. Let's go back and identify if this was y over r, and it's in quadrant 2, there's my y value, and here's my r value. Understand, though, that this problem we ignored the fact that cosine had to be negative, and my cosine is positive here. So one way to look at this is left, and when I do 25 minus 4, c squared minus b squared equals a squared, that's going to be the square root of 21, but it's negative because it's to the left. And that would have helped me remember that I needed the negative version of this. I needed the negative version of root 21 over 5 because of the quadrant it was in. So do you see how easy it is to make a mistake there if we're not following all of our lesson that we've learned, finding which quadrant it's in, looking where cosine is positive or negative in that quadrant, and now finding the rest of my function values. So let's take this last problem where I gave you a cotangent value, and let's use the idea of triangles and our quadrants to help us find all 5 remaining trig function values. I know that the cotangent is positive. Where does that happen? That happens in quadrant 1 and in quadrant 3. I know my sine value is negative. That happens in quadrant 3 and in quadrant 4. So where is my triangle? In quadrant 3. So I'm going to go ahead and draw my triangle in quadrant 3. And it doesn't have to be a perfect triangle. I just know that we always use that portion of the bow tie we started the very first unit with, the unit circle. And I know that it's left, so this is going to be negative, and it's down, so this is going to be negative. And I know that cotangent is adjacent over opposite. So I've got -1 and -3. I've got left 1 and left 3. I can still square that, which is 1, square that, which is 9, and find my radius is the square root of 10. I now know that theta is right here, and I can find every single trig function. I can do sine of theta is opposite over hypotenuse. I can do cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. I can do cotangent of theta is the reciprocal of that. That's going to be -1 over -3. Secant of theta is going to be root 10 over -1. And cosecant of theta is going to be root 10 over -3. Now we are still going to need to simplify these. This will come out to -3 root 10 over 10. This is going to come out to negative root 10 over 10. Will be positive 3. This will be positive 1/3, negative root 10, and negative root 10 over 3. And we have found all trig identity functions from the reference triangle right there. We knew our values had to be left and down. That gave us all of our negative values. Which ones came out positive? Tangent and cotangent in quadrant 3. Everything else is negative. Good luck.